Chapter 7. Writing chemical equations. In this chapter, you'll learn to write chemical equations as well as ionic equations. For writing chemical equations, the learning outcomes are you will be able to interpret chemical equations with state symbols and write balanced chemical equations with state symbols. So what is a chemical equation? A chemical equation shows what happens in a chemical reactions. It tells us which reactants and products are involved in the reaction, and the relative amounts of reactants and products, as well as the physical states of the reactants and products of the reaction. So in a chemical equation, it tells you about the reactants, the products, the amounts of reactant and products, as well as the physical states of reactant and products. For example, in this reaction of chlorine with sodium to form sodium chloride, you can see that 2 sodium reacts with 1 chlorine Cl2 to form 2 sodium chloride. You can see the type of chemicals that react to form the products, as well as the relative amount that need to react to form the product. So balancing a chemical equation. A balanced chemical equation must contain equal numbers of atoms of each element on both sides of the equation. For example, these are reactant, 2 hydrogen and this oxygen. These are reactant on the left hand side, and this is a product written on the right hand side. So chemical equation is balanced by adding a number in front of the chemical formula. For example, if I need to have 4 hydrogen, so I put 2 times 2 is 4 hydrogen in total. And all these G, G and L are the state symbols. So there are 4 different state symbols: S for solid, G for gas, L for liquid, and aqueous is AQ. Aqueous means soluble or dissolved in water in the form of a solution. Now, this arrow sign represents a reaction. So in other words, it means that the left hand side reactant react as reaction proceed in the direction of arrow, it forms the product. For example, reacting hydrogen and oxygen to get water, first you write down the chemical formula of reactants and products to get the chemical equation. So first you write hydrogen, H2, write O2 and H2O. Now obviously when you compare the before and after, you realize that there's 2 oxygen on the left hand side while there's only 1 oxygen on the right hand side. This is definitely not a balanced equation. So you check the number on both sides. If the equation is not balanced, you move on to the next step to balance the equation. If the equation on both sides of chemicals are balanced, then you can stop there. So in this case, you see 2 oxygen, and in the water there's only 1 oxygen, so definitely it's not balanced. So how do you balance it? So in order to balance the equation, you want to have 2 oxygen, you put a 2 in front of the water, so it means 2 times 2 hydrogen, 2 times 1 oxygen. So in total you have 4 hydrogen and 2 oxygen on the right hand side. However, it's still not balanced, because even though oxygen is balanced, the hydrogen is not balanced, because you have 4 hydrogen while the left hand side only there's 2. So you need to do something to the left hand side. So in this case, if you put a 2 in front of hydrogen, means 2 times hydrogen, you will look like this: 2 hydrogen, 2 H2, that means 4 hydrogen in total, and 1 oxygen means 2, 1 O2 means there's 2 oxygen atoms, and 2 water molecules. So if you count 1, 2, 1, 2, hydrogen 1, 2, 3, 4, and then right hand side is 1, 2, 3, 4. Therefore you actually have a balanced chemical equation, because the number of atoms on both sides are equal for all elements. Then you add the state symbol to indicate the physical state of each product and reactants. So in this case, you know hydrogen is a gas because G is a gas, oxygen is a gas, while the water form is a liquid. So you must remember, solid is represented by S, liquid is L, G is gas, and aqueous AQ. Aqueous means dissolve in water. It is not a pure substance but dissolve in water. For example, if you put aqueous sodium chloride, means sodium chloride dissolve in water. It's a mixture of sodium chloride and water. But L, liquid. Liquid means melted or molten. So if you have a sodium chloride liquid, it means that it's a pure melted or molten sodium chloride. It's different from the aqueous. Aqueous is a mixture of the substance and the water. Next, we come to the ionic equations. The learning outcome of this section is you will learn how to write the ionic equation with state symbols. What is ionic equation? An ionic equation is a simplified chemical equation. Simplified chemical equation that shows the reaction involving ions in aqueous solution. And what is spectator ion? In chemical reactions, there are ions that do not take part in any chemical reaction, and these are called the spectator ions. They are there before the reaction and there after the reaction. So let's take a look. For example, when you have hydrochloric acid and sodium hydroxide react to form sodium chloride and water. First, if you look at all these aqueous, as long as aqueous state, you can actually write them in terms of ions, because in HCl aqueous, it's basically a mixture of hydrogen and chloride ions moving in the water, because aqueous means there's water. So hydrogen and chloride ions in the water. Likewise for sodium hydroxide, aqueous means sodium ions and hydroxide ions in water. And sodium chloride is sodium ions and chloride ions in water. Now compare the before reaction and after reaction. Which ions were there before the reaction and still there after the reaction? So you realize that, hey, sodium is here and still there after reaction. Chloride is there before reaction and still there after reaction. So they are the spectator ion. Sodium has not changed. Chloride has not changed. So they are the spectator ions. So by removing them from the equation, we are left with hydrogen ions, hydroxide ions. How do you remove them? You compare both sides. Sodium, cross out, because they are there before and after, no change. Chloride, cancel out. What you left with? Hydrogen ion, hydroxide ions, and of course not forgetting the water. So you have hydrogen, hydroxide, and water. And this is the ionic equation. What's left is ionic equation. So, how to write ionic equation? First of all, you must have, let me emphasize, you must have a balanced chemical equation with state symbol. Without state symbol, you will not know which ions you need to break down. In this case, HCl aqueous, sodium hydroxide aqueous, sodium chloride aqueous, you know that these aqueous substances are the one they can break down into ions. So when you bring the ions, it looks like this. HCl become H plus and Cl minus. Sodium hydroxide is Na plus OH minus, becoming Na plus and Cl minus plus water. Now, why you did not break down the water? Because it is not aqueous, it is liquid. So any physical state that is solid, liquid, and gas, you do not need to break them down. Anything is aqueous, you break them down to ions. Then, by comparing the equation before and after reaction, you cancel out the spectator ions. So you see, you cancel out the sodium, you cancel out the chloride. What you're left with is ionic equation. Remember to write down ionic equation including state symbols. It's very important. Substances that do not ionize in solutions are insoluble solids, like metals, insoluble salts. So what you usually write behind for state symbol is S. So you do not break down any solid state. You also do not break down covalent molecules such as water, covalent liquids. Their state symbol is L, so you do not break down the solid or liquid or gases. So anything that state symbol is solid, liquid or gases, you do not need to break down. You only need to break down the ions. So you do not break down any of these solid, liquid or gas into ions. We're writing an equation. So these substances that are not broken down should be written in full. For example, H2O liquid, silver chloride solid. Okay, let's look at this reaction of sodium chloride and silver nitrate reaction. First, write a balanced chemical equation. Check its balance with state symbol. Now, among all these two reactants and two products, silver chloride is a solid state. So a solid need not break down, and the rest will be broken down into the ions. Sodium chloride, silver nitrate. Take note, this was not broken down, and the rest are broken down. So before reaction, nitrate was there. After it was there, so cancel off. Sodium and sodium cancel off. What you have left is a chloride, and the silver forms silver chloride. So after striking off, oops, it shouldn't be this. It should be striking off this one. Okay, so what you need to write down is chloride ion, silver ion, and the silver chloride. Now, silver nitrate and sodium chloride. So what happens is that when the silver and the chloride comes together, they join together to form precipitates. Precipitates are insoluble solid, the white solid that's formed. So when this ion combine, silver and chloride combine, they form silver chloride. This is an insoluble precipitate. And you take note that my nitrate and the sodium are still moving around freely in the solution. When they mix this solution and this solution together, they are all moving inside the solution. So sodium and nitrate remains unchanged throughout the reaction. They are still inside the solution, moving freely. So when we write our equation, they'll be cancelled on both sides.